Welcome to Astronomy Daily. I'm Anna, bringing you the latest and most exciting news from across the cosmos. Today, we've got a stellar lineup of stories that showcase just how dynamic our understanding of space continues to be. Coming up in the next 20 minutes, we'll explore a truly rare cosmic event that's unfolding relatively close to home. A pair of white dwarf stars on a collision course that will eventually create a supernova explosion brighter than 10 full moons. This first-of-its-kind discovery is giving astronomers unprecedented insight into these cosmic standard candles. We'll also dive into some space policy news as SpaceX steps in to launch a military GPS satellite that had been waiting in storage due to delays with United Launch Alliance's Vulcan rocket. This satellite shuffle reveals interesting developments in how the Space Force is adapting to ensure critical missions reach orbit on schedule. Then we'll head to the International Space Station with the Soyuz MS.27 mission, carrying a fascinating crew, including a NASA astronaut with an extraordinary background as both a Navy SEAL and a Harvard-educated doctor. Our planetary exploration takes us to Uranus, where new Hubble telescope data has revealed the ice giant's day is actually longer than we've thought for the past 4 decades. Those extra 28 seconds might seem small, but they're forcing scientists to recalibrate everything we know about the planet's coordinate system. And finally, we'll look at an ambitious proposal for a fleet of space telescopes working together to answer one of humanity's most profound questions: how common is life in the universe? The fascinating part is that even if this mission finds no signs of extraterrestrial life, it could still tell us volumes about our cosmic neighborhood. That's all ahead on today's episode of Astronomy Daily, your window to the wonders beyond our world. So let's get started. Astronomers have just made an unprecedented discovery that's captivating the scientific community: a pair of white dwarf stars locked in a deadly dance just 150 light years from Earth. This extremely rare binary system consists of 2 massive white dwarfs that are on a collision course, spiraling ever closer to each other in what will eventually result in one of the most spectacular explosions in the cosmos. White dwarfs are essentially the dense cores left behind when stars like our sun die. They pack roughly the mass of the sun into a volume about the size of Earth, making them incredibly dense. Finding 2 of these stellar remnants orbiting each other this closely is extraordinary, and the implications are even more fascinating. According to research published in Nature Astronomy, these 2 stars are already remarkably close, orbiting each other once roughly every 14 hours. But this leisurely encircling won't last forever. Over the next billion years, gravitational wave radiation will cause the stars to spiral even closer together. By the time they're about to go supernova, they'll be whipping around each other every 30 to 40 seconds. What makes this discovery truly significant is that it's the first direct observation of what astronomers believe is the most common cause of type 1, a supernovae. These cosmic explosions occur when a white dwarf gathers too much mass. In this case, the heavier of the pair will likely accumulate material from its partner through gravity, leading to one or both stars exploding. Lead researcher James Munday from the University of Warwick was understandably excited when he spotted this system, noting that for years a local and massive double white dwarf binary has been anticipated. His international team quickly used some of the world's largest optical telescopes to determine exactly how compact the system is, discovering that the 2 stars are separated by just 1/60th of the Earth-Sun distance. Type 1A supernovae are crucial tools for astronomers because they serve as standard candles, explosions with known brightness that allow scientists to calculate the distance between Earth and other galaxies. They're even used to test theories about the expansion of the universe. Having a front-row seat to the formation of such an event is unprecedented. When these stars eventually merge, the resulting explosion will be truly cataclysmic, about 1,000 trillion times more powerful than the most powerful nuclear bomb ever created. And while that sounds alarming, especially considering how close this system is to our solar system, we don't need to worry. The team's calculations indicate this cosmic spectacle won't happen for about 23 billion years. Co-author Ingrid Pellisoli points out that finding such a system relatively nearby suggests these binary white dwarf pairs must be fairly common throughout the galaxy. If they were rare, astronomers would have needed to look much further away to find one. She adds that this is just the beginning. as their survey searching for Type 1a supernova progenitors is ongoing, with more exciting discoveries likely on the horizon. This rare glimpse into the life cycle of stars provides a valuable piece in our understanding of cosmic evolution. By watching these white dwarfs over time, astronomers can refine their models of how these standard candles form and behave, ultimately improving our ability to measure the vast distances of space and understand the fundamental nature of our expanding universe. Next today. In a significant shift for the U.S. military's launch plans, Space Systems Command announced Monday that SpaceX will now deploy a Global Positioning System satellite originally scheduled to fly on United Launch Alliance's Vulcan rocket. This is no small matter. It represents the second time in just 6 months that the Space Force has had to reassign a military satellite to SpaceX due to continued delays with ULA's new Vulcan launch vehicle. The satellite in question, designated GPS-3 SV-08, is the 8th in a series of 10 advanced navigation satellites that provide critical positioning and timing signals for both military and civilian users worldwide. It had been sitting in storage at Lockheed Martin's factory in Colorado, essentially ready to go, but waiting for its ride to space. Thanks to this launch vehicle trade, as the Space Force calls it, the GPS satellite could reach orbit as early as the end of May, a dramatic acceleration compared to its uncertain timeline with ULA. What makes this particularly remarkable is how quickly the military can pivot when necessary. Colonel Jim Horn, senior material leader of launch execution, pointed out that this showcases the Space Force's ability to complete high-priority launches with just 3 months of preparation, compared to the typical planning cycle of 2 years. This rapid response capability isn't just a convenience. It's increasingly viewed as a strategic necessity. Frank Calvelli, the Pentagon's chief of space acquisition, had previously expressed significant concerns about ULA's manufacturing capabilities, writing in a letter to ULA's owners, Boeing and Lockheed Martin, that currently there is military satellite capability sitting on the ground due to Vulcan delays. The Vulcan rocket, which ULA hopes will eventually launch twice monthly, has only flown on 2 demonstration missions so far. While the Space Force did certify the rocket for military launches last month, ULA faces the daunting task of working through its massive backlog of 89 missions, a number that grew even larger after the Space Force awarded the company 19 additional launches just last week. This isn't the first time the military has had to pull this kind of maneuver. Last year, teams from the Space Force, SpaceX, and Lockheed Martin successfully executed what they called a Rapid Response Trailblazer mission, preparing a GPS satellite for launch on a Falcon 9 in less than 5 months rather than waiting for its ULA slot. That mission launched successfully in December. To maintain balance in its launch portfolio, the Space Force is making adjustments across its manifest. They'll be moving a future GPS payload from SpaceX's Falcon Heavy back to ULA's Vulcan, ensuring that the next 3 GPS satellites after this one will still fly on Vulcan once the rocket is ready. A similar compensation occurred after last year's reassignment. These advanced GPS-3 satellites represent a significant upgrade to the navigation constellation. They broadcast more accurate signals that are harder for adversaries to jam, and they include a new channel compatible with Europe's Galileo navigation network. This allows users to merge signals from both constellations to achieve even better position estimates, a capability that both military strategists and civilian applications are eager to utilize. With 2 more completed GPS-3 satellites already in storage and waiting for launch, plus an upgraded GPS-3F design set to begin launching in 2027, the pressure to get these capabilities into orbit remains high. This satellite swap demonstrates not just the Space Force's flexibility, but the growing importance of having redundant launch options to ensure national security assets can reach space when needed. The 4th crewed space launch of 2025 is now in the history books as Soyuz MS-27 successfully lifted off from the Baikonur Cosmodrome in Kazakhstan. The launch occurred right on schedule at 5:47 UTC on Tuesday, April 8th, carrying 3 crew members bound for the International Space Station. Leading the mission is veteran cosmonaut Sergei Ryzhikov, who's no stranger to space travel. This marks his 3rd journey beyond Earth's atmosphere, following previous missions in 2016 and 2020. During his 2nd flight, Ryzhikov even served as the commander of the International Space Station during Expedition 64, gaining valuable leadership experience that will serve him well on this new mission. Joining Ryzhikov are 2 first-time space travelers. Russian cosmonaut Alexei Zubritsky, a senior lieutenant in the Russian Air Force, is serving as one of the flight engineers. Born in Ukraine's Zaporizhia region in 1992, Zubritsky was selected for the cosmonaut program in 2018 after graduating from the Ivan Kozhedub National University of the Air Force. The second flight engineer position is filled by NASA astronaut Johnny Kim, whose background reads like an action movie script. Before becoming an astronaut, Kim served as a Navy SEAL, seeing combat in the Middle East where he earned a Silver Star. Not content with just military achievements, he went on to earn a mathematics degree summa cum laude and a medical degree from Harvard, becoming both a physician and a naval aviator before NASA selected him in 2017. The Soyuz spacecraft reached the station in just over 3 hours, docking to the Prytel module on the Russian segment at 9:03 UTC. This precise orbital ballet demonstrates the reliability of the Soyuz program, which continues to serve as a crucial transportation system for the international space community. With the arrival of Soyuz MS-27, the space station is temporarily home to 10 astronauts and cosmonauts. The new arrivals will join the existing Crew 10 and Soyuz MS-26 teams already aboard. This larger crew will work together during a handover period until Soyuz MS-26 undocks on April 20th, marking the end of Expedition 72 and the beginning of Expedition 73. Unlike typical Soyuz missions, which last about 6 months, this crew is scheduled for an extended stay of approximately 8 months. They won't return to Earth until December 8th, giving them ample time to conduct experiments and perform essential maintenance on the orbital outpost. Among their potential tasks is at least one spacewalk planned for the U.S. segment of the station. Johnny Kim, with his extensive training in EVA operations, is expected to participate in this critical work outside the protective shell of the ISS. The Soyuz MS-27 mission represents the continuity of international cooperation in space, despite geopolitical tensions on Earth. It's also the second Soyuz rocket launch of 2025 and the first of 2 planned crewed flights from Baikonur this year. The backup crew for this mission, already named as the prime crew for Soyuz MS-28, is scheduled to launch no earlier than November 27th. As these 3 explorers settle into their home for the next 8 months, they become part of the ongoing human presence in low Earth orbit that has now continued uninterrupted for over 2 decades, furthering our understanding of living and working in the challenging environment of space. Up next, new findings means new adjustments. Time to adjust our calendars for Uranus. The ice giant just got a longer day. Recent analysis of decade-long observations from the Hubble Space Telescope has revealed that Uranus takes 17 hours, 14 minutes, and 52 seconds to complete a full rotation on its axis. This new measurement adds 28 seconds to the previous estimate established by NASA's Voyager 2 spacecraft back in 1986. The original rotation period of 17 hours, 14 minutes, and 24 seconds was determined during Voyager 2's historic flyby, the first and so far only spacecraft visit to the distant planet. Scientists based that figure on radio signals from Uranus's auroras and direct measurements of its magnetic field. This value became the foundation for all coordinate systems and surface mapping of the pale turquoise world. However, this new research suggests astronomers may need to reconsider some of those maps. The Voyager 2 estimate contained inherent uncertainties that led to significant problems. Within just a couple of years after the spacecraft's brief encounter, the orientation of Uranus's magnetic axis became completely lost, resulting in a 180-degree error in the planet's longitude. Coordinate systems based on that outdated rotation period quickly became unreliable. To resolve this astronomical dilemma, a team led by Laurent Lamy from the Paris Observatory undertook the painstaking task of tracking Uranus's auroras using Hubble data collected between 2011 and 2022. By monitoring these luminous atmospheric displays over more than a decade, the researchers pinpointed the planet's magnetic poles with unprecedented accuracy, enabling them to calculate a more precise rotation period. The continuous observations from Hubble were crucial, Lamy noted. Without this wealth of data, it would have been impossible to detect the periodic signal with the level of accuracy we achieved. This methodical approach offers benefits beyond just updating a planetary factoid. The technique can now be applied to determine rotation rates for any celestial body with a magnetic field and auroras, not only within our solar system, but potentially for exoplanets and other distant worlds as well. The updated rotation period provides astronomers with a much more reliable coordinate system for Uranus, one expected to remain accurate for decades until future missions can gather even more precise data. This improvement could prove invaluable for planning those future expeditions to Uranus, particularly in designing orbital tours and selecting suitable atmospheric entry sites for probes. While 28 seconds might seem like a minor adjustment in astronomical terms, this level of precision represents a significant refinement in our understanding of the seventh planet from the Sun. The findings published in the journal Nature Astronomy earlier this month demonstrate how continued observations from Earth-based instruments can still enhance our knowledge of even the most distant planets in our solar system. Finally today, in our search for life beyond Earth, scientists are developing increasingly sophisticated tools to answer one of humanity's most profound questions. Are we alone? A groundbreaking mission concept called LIFE, the Large Interferometer for Exoplanets, aims to tackle this question with unprecedented clarity. LIFE proposes deploying a fleet of 4 space telescopes working in perfect coordination around a central combiner spacecraft. These telescopes would fly in formation tens to hundreds of meters apart, collectively functioning as a powerful interferometer that combines their light detections to achieve what no single telescope could. What makes LIFE particularly revolutionary is its planned use of nulling interferometry, a clever technique that cancels out the overwhelming glare from stars by combining their light out of phase. This creates what scientists call destructive interference, effectively dimming the star's brilliance while preserving the faint light from any orbiting planets. Rather than producing direct images, LIFE would observe in the mid-infrared spectrum, allowing it to spectroscopically analyze the light from exoplanets and reveal the molecular composition of their atmospheres. The mission would target dozens of Earth-sized planets residing in the habitable zones of their stars, searching for telltale biosignatures, atmospheric gases that could indicate the presence of life. These biosignatures include the obvious candidates like oxygen and water vapor, but also compounds such as ozone, methane, nitrous oxide, dimethyl sulfide, and phosphine. The detection of certain combinations of these molecules could provide compelling evidence for biological activity. Currently, LIFE remains a concept spearheaded by researchers at ETH Zurich in Switzerland. It hasn't yet been adopted by a space agency, but its scientific potential is already being carefully assessed. A fascinating aspect of the LIFE mission is that it could deliver profound insights, even if it fails to detect any biosignatures at all. Using sophisticated statistical models, researchers have determined that LIFE would need to examine only 40 to 80 exoplanets without finding any signs of life to conclude with confidence that fewer than 10 to 20% of similar planets in the universe harbor life. A simple positive detection would change everything, notes astronomer Daniel Angerhausen of ETH Zurich. But even if we don't detect life, we'll quantify how rare or common planets with detectable biosignatures really might be. The team employed both Bayesian and frequentist statistical approaches to reach this conclusion, ensuring their findings are robust across different mathematical frameworks. As the sample size increases, if no biosignatures are detected, scientists could place increasingly stringent limits on the prevalence of life in our galaxy. Of course, the researchers acknowledge certain challenges. Some biosignatures might be missed due to detection limitations, or planets might be mistakenly included in the potentially habitable category. It's not just about how many planets we observe, Angerhausen explains. It's about asking the right questions and how confident we can be in seeing or not seeing what we're searching for. Whether life ultimately finds inhabited worlds or determines they're exceedingly rare, the mission would fundamentally transform our understanding of life's place in the cosmos. In either scenario, humanity would gain unprecedented insight into our cosmic significance, either as one among many living worlds or as something far more unique than we previously imagined. Well, that's all for today's cosmic journey. What an incredible set of discoveries we've explored together. From those doomed white dwarf stars destined for a spectacular collision billions of years from now, to the Space Force's agile satellite launch maneuvers, to the successful Soyuz mission carrying international crew members to the ISS. We've also learned that Uranus turns a bit more slowly than we thought. Those extra 28 seconds might seem trivial to us, but they represent a significant refinement in our understanding of the ice giant. And the proposed Life Telescope Array could finally help us determine whether habitable worlds are cosmic rarities or scattered abundantly throughout our galaxy. What links all these stories is humanity's relentless curiosity about the universe we inhabit. Each discovery, each mission, each new measurement brings us closer to understanding our cosmic neighborhood and our place within it. I'm Anna, and I've been delighted to share these fascinating space developments with you on Astronomy Daily. If you're hungry for more space news, remember to visit our website at astronomydaily.io, where our newsfeed is constantly updating with the latest discoveries and developments from across the cosmos. You'll also find all our previous episodes there if you'd like to catch up on anything you've missed. And don't forget to join our community on social media. You can find Astro Daily Pod on X, Facebook, YouTube Music, Instagram, and TikTok. Follow us to get updates, behind-the-scenes content, and join the conversation about our amazing universe. Until next time, keep looking up. There's always something incredible happening in the cosmos, and we'll be here to tell you all about it. Thanks for listening to Astronomy Daily.